Welcome back to my channel Coding Clean, and today in this video we will be learning about operators in C++. But before learning about operators, it's important to know a very simple definition that what is an expression? An expression is the combination of operands and operators. We have different kind of expressions, mathematical expressions and logical expressions and Boolean expressions, and we'll talk about them from time to time. But look at these examples. num1 plus num2, it is an expression. We have first operand, then the second operand, and then an operator. So this whole combination is called an expression. The first type of operators in C++ are called arithmetic operators. And we are all familiar with these operators because of mathematics. We have been using them for years now. So the first operator that is used for addition is called the plus operator. And the example of that is if there are two variables, num1 and num2, we can add the values of these variables using the plus operator by putting the plus operator between them. Then we have a minus operator. It works exactly the same way. And then we use a static operator for multiplication. So if we want to multiply the values of two variables or two numbers or two constants, we can put the static operator between them and it's going to return the product or the multiplication of those values. We use two operators for division. One is called simple integer division operator, the / in C++. And what it does, that it divides num1, which is a variable, by num2, and it returns the quotient of division. Whereas the modulus operator, it's called the modulus operator, the % symbol on the keyboard. It is not used for calculating the percentage in C++, but it is used for dividing the first value by the second value, and it returns the remainder of the division. So let's write a program to explain these concepts in detail. I am going to declare two integer variables and I'm going to call it number1, and I'm going to store the value 7 in that variable. I am declaring another variable called number2. Let's put the value 5. Then a third variable called result to store the result of the expressions. I want to add number1 using the plus operator, and I'm going to put number 2. This operator returns the sum of these two values, and then we are storing that result in the result variable. Let's see out on screen, result and L. Save changes, compile the code, and run the program. And as you can see, the sum of these two variables is 12. Similarly, you can perform subtraction, but let's do multiplication. Just change this to static, and the static operator is used for multiplication. So it's going to multiply the value of number 1 and number 2 and return the product and store that in the result. So let's run the program again, and we see the value 35, which is the product of 7 and 5. These two operators are important. One is called simple division, the other is called modulus operator. The simple division we are familiar with, but let's use the modulus operator. So I'm going to change the static to % symbol, which is the modulus operator in C++, and it's going to divide number 1 by number 2 and returns the remainder of the division, and we are storing that in the result variable. So if you divide 7 by 5, you get the remainder 2, and I think it's going to be 2. So these are arithmetic operators, and whenever you want to use them, you have to put this in the middle, and it requires two operands. So all these operators are called binary operators. Bi means two, so it requires two operands, one to the left and one to the right. Now let's talk about relational operators in C++. These operators are used for comparison. If you want to compare two values, that whether the first value is smaller than or greater than or equal to or not equal to the second value, we use these operators. The first operator is called greater than operator, and this character will be used for greater than operator. The second is less than operator, and then we have the equality operator. Remember to not confuse this with assignment. Assignment is a single equal sign in C++. For equality, we use double assignment. And this one is not equal to. You put sign of exclamation and then one assignment. And this combine is called not equal to operator. Then we have greater than or equal to and less than or equal to. So these are the combinations of the equality and greaterness, and this is the combination of less than or equal to. So let's write a program and explain this concept. But before that, you should read this note that all these operators returns either true or false, because they answer the question, is it true or is it false? So let's write a program. I'm going to declare a Boolean variable. So I'm going to say bool. I'm going to call it result. And the reason I'm declaring a Boolean variable is because all these operators either returns true or false. So what I'm going to do is to use all these operators with literal values. So let's say 8 is greater than 5. This operator will either return true or false. In this case, 8 is greater than 5, so it's going to return true. And that value will be assigned to the Boolean variable, because the value to the right of the assignment must match the data type of the left-hand side variable. So that is why I declared a Boolean variable. And in C++, if you have watched my previous video about data types, the Boolean value is represented by the digit 1 and false value is represented by the digit 0. So if I see out the value, it's going to return 1, and it's going to display 1 because 1 is for true and 0 is for false. So let's compile and run the program, and the value is 1. If I change this from greater than to less than operator, save changes, in this case, it's going to return false because 8 is less than 5. This operator less than return false because 8 is not less than 5. So the result will be 0 in C++, as you can see here. If you want to see the actual word true or false, as I explained in my previous videos, you have to use a manipulator called bool alpha. All you have to do is to put bool alpha before the result and then insert a stream insertion operator. And for that, you have to include the header file called iomanip, stands for IO manipulation. So if I save changes and run the program, it's going to return false because 8 is not less than 5. Let's check for equality. If I put the double assignment operator, which is for equality, then it's going to first perform this operation because the precedence of the equality operator is higher than assignment. Assignment has the lowest priority or precedence. 8 equals to 5. This operator returns false because 8 is not equal to 5. So we are going to see false on screen. And if I change 5 to 8, 8 equals to 8, the result is true. The result of this whole expression is true, and that true value will be stored in result, which is 1, and that 1 value will be converted into the word true by bool alpha. So let's run the program. These last two operators are also straightforward. They basically check two things, that whether the left hand value is equal to 8 or greater than 8. So you have to put the greater than symbol first. Students get confused that whether to put this symbol before this assignment or after. Remember that the operator says greater than or equal to. That means greater than comes first. So you should put the greater than operator first and then this assignment. And combine, it is read as greater than or equal to. Now it checks two things, whether the left hand value is greater than, no it is not. But then again the second part says is equal to, yes 8 is equal to 8. So whether it's greater than or equal to 8, the result will be true. So it's going to assign true to the result variable, and we should see true on screen. Run the program, and true is there. And you can use the less than or equal to operator the same way. And finally, we are going to talk about logical operators. These operators are used to check multiple conditions. In the previous example of relational operator, we saw only one expression. But here we have multiple expressions, and those expressions return true or false, and we want to check multiple conditions. Let's talk about the AND operator. AND operator is represented by these two characters in C++, and OR operators is represented by these two vertical bars, and the NOT operator is the sign of exclamation. Let's read the definition. The AND operator returns true if and only if both inputs or sub-expressions are true. So if you look at the AND operator, this is an example. We have a sub-expression to the left of this AND operator and a sub-expression to the right of this AND operator. And if those sub-expression both returns true, then the AND operator also returns true. Otherwise, it returns false in other cases. If any of the sub-expression or both of those expressions are false, the AND operator will return false. So let's see that in a demo. I'm going to declare a Boolean variable called result, and I'm going to put exactly the same thing. 2 is greater than 1. This is one sub-expression, and then put the AND operator, and then check the second sub-expression. 7 is less than 9. In this case, the first sub-expression is using the relational operator greater than. 2 is greater than 1. If it is true, this will return true. So the result of the first sub-expression will be true, and the result of the second sub-expression says 7 is less than 9. It is also true because 7 is less than 9, and this operator returns true. So when both of the sub-expression return true, the AND operation as a whole will return true, and that value be assigned to the result. So let's check this out. Cout bool alpha, and then result and endl. Save changes, compile and run the program, and it says true. So the point to remember is that this operator only returns true if both of the sub-expression, the left sub-expression and the right sub-expression, returns true. Let's see the OR operation. The OR operator returns false only if both are false, otherwise it returns true in all other cases. That means the only time the OR operator will return false if both the left sub-expression and the right sub-expression both returns false, then it returns false. Otherwise, if one of them is true or both of them is true, it returns true. So if I just change the AND operator to OR, two pipe symbols, or sometimes called two vertical bars, then even if I change this to, for example, the first one or maybe the second one, 7 is less than, let's say 70, or let's say 7 is less than 19, or maybe 2 is greater than 1. This sub-expression is true, but the right sub-expression is false because 7 is less than 2. It's not true, it's false. So false and true will always return true. The only time this operator returns false if both the sub-expression returns false, right? So in this case, the first one is true, so it's going to not even check the second expression, because if one of them is true, it returns true. So if I just save changes, you will see true on screen. Yeah, true. And if I change this one to false, for example, and look at this situation, 2 is greater than 11, false, 7 is less than 2, false. So if both of the sub-expression is false, only in that case the OR operator returns false. In all other cases, if both are true or if one of them is true, it returns true. So and this is that's why I written the definition. Only if both are false, then it returns false. Otherwise, it returns true for all other situations. So if I save changes, in this case, it's going to return false, as you can see here. And if I make one of them true, it's going to return true, right? And the NOT operator is very interesting. It says that it converts true to false and false to true. So let me just remove this right sub-expression so that I can make it simple for you. 20 is greater than 11. Is it true? Yes, it's true, and it's going to return true. If you look at the screen, it says true. But if I put the NOT operator, it's like an inverter. It changes true to false and false to true. So this is true, right? The result of this whole sub-expression will be true, and NOT will convert it into false. So the result will be false now. It's false. And similarly, if it is false, if I say 2 is greater than 11, which is false, the NOT will convert it into true. So if I save changes, recompile and run the program, you're going to see true. So thanks for watching. See you next time.